Hello everyone, welcome to Math Advice. In this video, let me see an example under Fourier series. Here I am going to take f of x as x cos x in the interval 0, 2 pi and let me see how to expand this function as a Fourier series in the given interval 0, 2 pi. Before that, let me have a short look over the important formulas that we are going to use in the problem. The very first one is an important formula, that's a Bernoullis Formula. If we are in the integration, if we are having product of two functions inside the integral, then we make use of this formula to evaluate the integral. That is, integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 minus etc. Here both u and v are functions of x, where u dash is nothing but du by dx. That is, once you have to differentiate u with respect to x, and u double dash is d square u by dx square. That is, you have to differentiate that twice with respect to x. So that is u dash u double dash are successive derivatives, whereas your v is nothing but your function of x. So once you have to integrate v, that is v1 is nothing but integral v dx and v2 is integral v1 dx etc. So v1, v2, v3 etc. are successive integrals. So u dash u double dash are successive derivatives, whereas v1, v2 are successive integrals. So with that, let me enter into a recapitulation of these formulas that we have already come across in your school days. That is, sin 2a is equal to 2 sin a cos a, and sin squared a is equal to 1 minus cos 2a divided by 2, whereas cos squared a is equal to 1 plus cos 2a divided by 2. And this is a basic integration and differentiation formula. Let me have a short look over this. Integral x bar n dx is equal to x bar n plus 1 divided by n plus 1. Suppose if you are going to integrate x square with respect to x, what happens? That is, you have to increase the power by 1 and write that power by in the denominator. So that is x square dx is x cube by 3. That is, in the case of differentiation, suppose if you are going to differentiate, that is d by dx of x bar n is equal to nx bar n minus 1. That is, suppose if you are going to differentiate the same function x square with respect to x, what happens? First you have to write the power and reduce this power by 1. That is 2 minus 1. That is 2x. Am I right? Now, integral sin x dx is equal to minus cos x, whereas integral cos x dx is equal to sin x. Whereas integral sin 2x dx is equal to minus cos 2x divided by 2, and integral cos 2x dx is equal to sin 2x divided by 2. So in general, we have to write integral sin nx dx is equal to minus of cos nx divided by n, whereas minus cos nx dx is equal to sin nx divided by n. So this is the important formula when we are having the product of functions inside the integration. So we make use of this formula to split the integral into 2. So for that, let me have a short look over this formula. From this alone, we make use of calculating 2 sin a cos b or whatever that may be given here, right? So sin a plus b is equal to sin a cos b plus cos a sin b, and sin a minus b equal to the same formula. Instead of plus, here you have minus, and cos a plus b equal to cos a cos b minus sin a sin b, whereas cos a minus b equal to the same formula here itself. So look at here, cos a plus b, here you have plus, okay? So cos a minus b is equal to cos a cos b plus sin a sin b, right? Now 2 sin a cos b is equal to, that is 2 sin a cos b. So if you want this term 2 times means you have to add, that is sin a plus b plus sin a minus b. Suppose if you need 2 cos a sin b, this term, what happens? Here you have minus, so for that you have to subtract, that is sin a plus b minus sin a minus b. Like that, cos a cos b, 2 cos a cos b is equal to, you have to add these two, that is cos a plus b plus cos a minus b. Suppose if you need 2 sin a sin b, that is 2 sin a sin b, so here you have minus, so you want to make it as plus. For that, you have to subtract this one minus cos a plus b, that is cos a minus b minus cos a plus b. So just remember this formula, so no need to mug up this formula. You just know the basic formulas of sin a plus b, sin a minus b, and cos a plus b and cos a minus b. From that you can write down these values of 2 sin a cos b or 2 cos a cos sin b, whatever that may be, that is required in the problem, okay? And while substituting the limits, you should know the limit values of cosine and sine terms. So cos 0 is equal to 1, whereas sin 0 is equal to 0. cos 2 pi is equal to 1, whereas sin 2 pi is equal to 0, and cos n pi is equal to minus 1 whole power n, sin n pi is equal to 0, cos 2 n pi is equal to 1, whereas sin 2 n pi is equal to 0. This holds only if n is an integer, but here in 0 to interval we take only the integer value, so here we take sin 2 n pi is equal to 0, whereas cos n plus 1 2 pi is equal to 1, and sin n plus 1 2 pi is equal to 0. I think now you ask the question how would this will come, because this is of the form cos a plus b, right? If you take 2 pi inside, you have 2n pi plus 2 pi. This is of the form cos a plus b. Cos a plus b is nothing but cos a cos b plus sin a sin b product, okay, sin b. So you know sin 2n pi, sin 2 pi, these are 0, whereas cos 2n pi and cos 2 pi is 1, so 1 product 1, 1. Like this you have to evaluate and find the value of cos n minus 1 2 pi also, that is plus 1, whereas sin n plus 1, this is of the form sin a plus b, okay. So while substituting and evaluating, you get 0 itself. So sin n plus 1 2 pi is equal to 0, and sin n minus 1 2 pi is equal to 0. So also we have to note one more point here in finding the a and bn value. So you know how to calculate a and bn by using the formulas, that is using Euler's formula we calculate, right? So that is 1 by pi integral 0 to 2 pi f of x cos n x dx. This formula gives you the value of a n, whereas 1 by pi integral 0 to 2 pi f of x sin n x dx. This formula gives you the value of bn. So you calculate the two Fourier coefficients a and bn by make use of this formula. Suppose in the values of after integrating and substituting the limits, if you get the denominator, so in either of the constant, if it is what, don't worry about the numerator, okay. So if the denominator consists of the term n square minus 1, then we have to find the particular case, that is we go for calculating a1 and b1, okay. So if both of them consist of the term n square minus 1, so you have to calculate a1 and b1. a1 is calculated by just replacing n by 1. What happens? a1 is equal to, here you replace n by 1. That is a1 is equal to 1 by pi 0 to 2 pi f of x cos x dx. This is the formula for calculating a1. Likewise, your b1 is, here itself you just replace this n by 1. So that is equal to 1 by pi integral 0 to 2 pi f of x sin x dx, right? So from the general formula, you just substituting n is equal to 1, so you get a1 and b1. This is a very important point you have to remember. Now let me have a short look over what is the general form of the Fourier series, along with what are the formulas we are going to use to calculate the Fourier coefficients a0, an and bn in short. So this is general form. In pi form we have discussed now. The given function is in the interval 0 to 2 pi alone. So the general form of the Fourier series is f of x equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos n x plus sigma n is equal to 1 to infinity bn sin n x. Here a0 is calculated by make use of the formula 1 by pi 0 to 2 pi f of x dx, and an is calculated by make use of the formula 1 by pi integral 0 to 2 pi f of x cos n x dx, and bn is calculated by make use of the formula 1 by pi integral 0 to 2 pi f of x sin n x dx. So with this short introduction, let me now enter into the problem. Expand f of x equal to, here given as the function is x cos x as a Fourier series in the interval 0 to 2 pi. So here first write down what is given function. So given your f of x is equal to x cos x, that is given in the interval 0, 2 pi. So as usual, first write down general form of the Fourier series, that is let f of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos n x plus sigma n is equal to 1 to infinity bn sin n x. You take this as equation number 1, where a0 is calculated by make use of the formula 1 by pi integral 0 to 2 pi f of x dx. You take this as equation number 2, and an is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. You take this as equation number 3, and bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. You takes as equation number 4. So by making use of these three formula, let us first calculate the values of a naught, an and bn and substitute in equation 1, the problem will be over. Okay, let me first calculate the value of a naught. So from equation 2, your a naught is equal to 1 by pi integral 0 to 2 pi f of x dx. So that is equal to 1 by pi integral 0 to 2 pi your f of x, that is what the given function. So your f of x is nothing but given function is x cos x dx, right? So here you take x as u and cos x as v. You know already integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. right? So here first you have to take x as u and cos x as v. While integrating you get 1 by pi u is nothing but x, v1 integrating cos x you get plus sin x, u v1 over next minus u dash v2 minus u dash, that is this is your u, right? So just differentiating x you get 1 and this is your v, right? This is your u, this is your v1. So v1 is nothing but while integrating sin x what you get minus cos x. So we may not proceed further because in your next term plus while you differentiating this is your u dash and this is your v2. While you differentiating this 1, that is u double dash becomes 0, right? So we can't proceed further. So let me stop this up to this. So the limit from 0 to 2 pi. So that is 1 by pi. Let me simplifying this by making minus and minus as plus. So x sin x plus cos x with the limit from 0 to 2 pi. Let me first substitute the upper limit. So if you substitute the upper limit here, first let me mark the x portion. So these three portion we are having x. So if you replace x by 2 pi in the first term, so first look at the sign of 2 pi. As you know already, sin 2 pi is nothing but 0. So 0 into anything 0 plus cos 2 pi value is 1. If you replace this x by 2 pi, cos 2 pi. So you get 1 minus, coming to the lower limit, if you substitute 0 for x, what happens? 0 into anything 0 plus cos 0. If you replace this x by 0, you get cos 0. Cos 0 value is 1. So simplifying this, that is equal to 1 by pi 1 minus 1. What happens? 1 minus 1 is 0. That is 1 by pi of 0. So 1 by pi of 0 is nothing but a naught is nothing but 0. So the value of Fourier coefficient a naught is calculated as 0. Next we calculate the value of a n. So from equation 3, your a n is equal to 1 by pi. First let me write down the general formula for calculating a n. 1 by pi integral 0 to 2 pi f of x cos nx dx. So what is the given function f of x? Next step, let me replace f of x by 0 to 2 pi f of x by x cos x, right? X cos x cos nx dx. What I am going to do next is 1 by pi integral 0 to 2 pi. I have to take this cos nx to the front first and next I have to take cos. So cos nx cos x. So multiplication, that is interchanging the position doesn't change the value of the integral. Am I right? So that is dx. In your next step, I am going to multiply, that is 1 by pi integral 0 to 2 pi. So by combining these two, here look at here, this is the product of three functions, that is 1, 2, 3. Both of them are involving. Here the integral also with respect to x, all of them are in terms of x. So we doesn't have any formula to evaluate integral involving three functions. So we have to convert this in terms of 2. For that, let me combine these two, right? This is of the form cos A cos B. So you know the formula for 2 cos A cos B, right? 2 cos A cos B. Am I right? 2 cos A cos B is equal to cos A plus B plus cos A minus B. A minus. Okay. So by make use of this formula, so for that what I am going to do here is, so we have the formula for 2 cos A cos B. So here we doesn't have 2. So for that we have to multiply, that is multiply and divide by 2. Okay, doesn't affect the value of the integral. So cos nx cos x dx. This is of the form 2 cos A cos B. Instead of A, here you have nx. Instead of B, here you have x. So in your next term, 1 by 2 pi integral 0 to 2 pi x cos A plus B. That is cos A is nothing but nx, right? Nx plus your B is x. So cos A plus B plus cos A minus B. A is nothing but nx minus x of dx. In your next term, let me take x as a common term and take it outside from both cosines. Right? This is for a simple calculation for the values of an. Okay? This simplified our calculation. That's why. Okay? So your an is equal to 1 by 2 pi integral 0 to 2 pi x product. Okay? Cos of, if you take this x outside, what happens? N plus 1x, here n minus 1x, right? So x product cos n plus 1x, here I have to take this x outside of this parenthesis, cos n plus 1x plus cos n minus 1x of dx. Let me now divide this integral into 2. Now it will be easy for us to integrate. That's why we make use of the trigonometric formula. Okay. So now that is equal to 1 by 2 pi. What I am going to do here is, you take x inside and just split the integral into 2. Separate integral. Okay. That is integral 0 to 2 pi x cos n plus 1x dx is one of the integral, plus 1 by 2 pi of integral 0 to 2 pi x cos n minus 1x dx as your next integral. Now what I am going to do here is, I have to separately calculate these two integrals and substitute here. So for that I have to take the first integral as I1 and plus, here you have plus symbol, plus the second integral as I2, right? So this is your an. You take this as equation, some general equation A, okay, uppercase A. So first let me calculate I1. I1 is 1 by 2 pi integral 0 to 2 pi x cos n plus 1x dx, right? So now your I1 is equal to 1 by 2 pi integral 0 to 2 pi x cos n plus 1x dx. Now this is of the form uv, right? uv, you know the formula for integral uv dx, isn't it? That is uv1 minus u dash v2 plus etc. So that is equal to 1 by 2 pi of u, that is nothing but, first one is uv1, right? U is nothing but x, v1 is nothing but cos n plus, while you integrating cos n plus 1x, you get v1, right? So cos n plus 1x, while you integrating, you get sin n plus 1x divided by n plus 1, right? Now this is your u and this is your v1. Next minus u dash. U dash is nothing but, now you have to, first term you have to differentiate, the second term you have to integrate. Okay, alternatively you put plus minus. Okay, so now you have to differentiate this x, you get plus 1. Now integrating this v1. V1 is nothing but sin n plus 1x by n plus 1. Here n, the denominator n plus 1 is a constant, so keep it as it is. While you integrating sin n plus 1x, you get minus cos n plus 1x divided by n plus 1. Already you have n plus 1 the denominator. So here n plus 1 the whole square with the limit from 0 to 2 pi. Let me now simplify these symbols. So this is minus into minus plus, right? So 1 by 2 pi of x sin n plus 1x divided by n plus 1 plus cos n plus 1x divided by n plus 1 the whole square with the limit from 0 to 2 pi. Now let me substitute the limit. For that, first substitute upper limit. Okay, So that is equal to 1 by 2 pi of, put a big parenthesis, inside that you have sub parenthesis like this, okay. So first let me substitute upper limit. So let me mark the portions of x first. So now here already I told you sin n plus 1 2 pi is sin of n plus 1 2 pi value is 0, okay. So if you replace this x by 2 pi, what happens? This term becomes 0 plus cos n plus 1 2 pi. You know cos n plus 1 2 pi value is 1, okay. So that is 1 divided by n plus 1 the whole square, minus, coming to the lower limit, if you substitute 0, so first if you substitute 0, what happens? 0 into anything? 0, plus cos n plus 1 0, that is 0, cos 0 value is, cos 0 is 1, okay. So that is equal to 1 divided by n plus 1 the whole square. That's all. Let me simplifying this. It is 1 by 2 pi 1 divided by n plus 1 the whole square, minus plus, so you have minus 1 divided by n plus 1 the whole square. What happens? So same magnitude, opposite sign, so both of the term being cancelled, right? So you get that is equal to 1 by 2 pi of 0, so that is equal to 0. So the I1 value we have obtained is 0. So let me substitute in equation A. So I1 value we have calculated is 0, plus, let me now calculate the value of I2. I2 is nothing but integral, that is 1 by 2 pi of integral 0 to 2 pi x cos n minus 1x dx, okay. That is, now your I2 is equal to 1 by 2 pi integral 0 to 2 pi x cos n minus 1x dx. Now substitute Bernoullis formula. So for that you have to take the first term as u and second term as v, that is integral uv dx is equal to u v1 minus u dash v2 plus etc, isn't it? So that is 1 by 2 pi of u is nothing but x, v1, while you integrating cos n minus 1x you get sin n minus 1x divided by n minus 1 minus u dash v2. U dash is nothing but, first this is your u and this is your v1, isn't it? So now you differentiating x you get 1 and v2 is nothing but integrating v1. So here you have n minus 1 in the denominator of v1, so take it as a constant. So when you integrating sin n minus 1x you get minus cos n minus 1x divided by n minus 1. Already you have one more n minus 1 in the denominator, so n minus 1 the whole square. Now the limit from 0 to 2 pi. Let me simplify first and then go for substitution of the limit. So minus minus here becomes positive. So 1 by 2 pi x sin n minus 1x divided by n minus 1 minus n minus becomes positive cos n minus 1x divided by n minus 1 whole square. Now the limit from 0 to 2 pi. Now let me substitute the limits. So 1 by 2 pi, let me mark the positions of x. So these three positions we have x. So put a big parenthesis, inside that you have sub parenthesis for upper and lower limit, okay. So first let me substitute x for 2 pi. What happens? So here we have, in two places here we have to substitute 2 pi. First we look at the sin term. Sin n minus 1 2 pi. As I told you already, sin n minus 1 2 pi is 0. So 0 into anything? 0. Plus, you know the value of cos n minus 1 2 pi. Cos n minus 2 pi is plus 1. So 1 divided by n minus 1 the whole square. So upper limit over, minus lower limit. Coming to the lower limit, if you replace x by 0, if you replace this x by 0, what happens? 0 into anything? 0. Plus cos n minus 1 0. That is nothing but cos 0. Cos 0 value is 1. So 1 divided by n minus 1 the whole square. That's all. So that is equal to 1 by 2 pi of 1 divided by n minus 1 the whole square minus 1 divided by n minus 1 whole square. What happens? These two are same in magnitude, opposite in sign. So both of them being cancelled. So you get 1 by 2 pi of 0. That is 0. That is the value of I2, we get the value 0. So let me substitute in equation A. So I1 also 0 and also the value of I2 also 0. So here an is equal to 0. If an is equal to 0, look at the previous term whether it holds for all values of n or is there any restrictions. For that, look at the value of I1. In I1 the previous term you have n plus 1, whereas in I2 you have the previous term you have n minus 1. So with this, that is understood that this holds only for all values of n except at n equal to 1, because in the both denominator and numerator you have n plus 1 and n minus 1. So if you substitute n is equal to 1 means definitely the series becomes infinity. Okay, so for that, to avoid that, so we have to take this value of n for n is equal to, instead of taking the summation n is equal to 1 to infinity, we have to take the summation from 2 to infinity, and so that we have to calculate the value of a1. That's why in the initially I have told that whether if the denominator of an or bn consists of the terms n square minus 1 in the denominator means definitely we go for the calculation of a1. Okay, so now let me calculate the value of a1. So now here a1, so you know the formula for an is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. Now just replace n by 1. What happens? That is a1 is equal to 1 by pi 0 to 2 pi f of x cos x dx. That's all. Just replace, next step, replace f of x by the given function, that is 0 to 2 pi. Here f of x is x cos x, product cos x dx. What happens? Cos x product cos x is nothing but cos square x, isn't it? 0 to 2 pi x cos square x dx. You know the formula for cos square a. Cos square a is equal to 1 plus cos 2a divided by 2. Instead of a, here you have x, right? So that is equal to 1 by pi integral 0 to 2 pi x. So here you have cos square a. So cos square x. So cos square x is equal to 1 plus cos 2x divided by 2. Okay, of dx. You take 2 outside, so that is 1 by 2 pi integral 0 to 2 pi x product 1 plus cos 2x dx. Let me take x inside to simplify our integration. Okay, so that is your a1 is equal to 1 by 2 pi integral 0 to 2 pi. If you take x inside, what happens? X plus x cos 2x dx, isn't it? So x plus x cos 2x dx. Let me separate this integral into 2, that is 1 by 2 pi, or otherwise you can integrate this directly too, that's not a problem. Okay, integral 0 to 2 pi x dx plus 1 by 2 pi integral 0 to 2 pi x cos 2x dx. So this is the simple integration, but here you make use of the Bernoullis formula, integral uv dx, right? Integral uv dx is equal to u v1 minus u dash v2 plus etc, right? So that is equal to 1 by 2 pi. While you integrating x, you get x square divided by 2 with the limit from 0 to 2 pi plus 1 by 2 pi of applying the Bernoullis formula, that is u v1. U is nothing but x. v1 is integrating cos 2x, you get sin 2x divided by 2. Am I right? Sin 2x divided by 2 minus u dash v2. This is your u and this is your v1. U dash is nothing but 1. While you differentiating x, you get 1. Now next you have to integrate v1. So you have to take 2 as a constant, that is in the denominator. While integrating sin 2x, you get minus cos 2x divided by 2. Already you have 2 in the denominator, so 2 square. So with the limit from 0 to 2 pi. Let me simplify this by making minus and minus as plus in the next step. So write the remaining terms as it is. So x square by 2, the limit from 0 to 2 pi plus 1 by 2 pi of x sine 2x divided by 2. Here itself we make a mistake, that is plus. Okay, sorry, here itself we made one more change, that is minus and minus becomes plus. Cos 2x divided by 2 square is nothing but 4. Am I right? With the limit from 0 to 2 pi. Let me substitute both upper limit and lower limit. So in the first term, if you substitute upper limit, what happened? X square. If you substitute upper limit, 2 pi. So 2 pi the whole square is nothing but 4 pi square divided by 2 minus coming to the lower limit 0 square by 2, that is 0 itself. Okay, plus 1 by 2 pi of, when you substituting the upper limit, what happens? So look at, first let me mark the positions of x. So at these three positions we have x. So for the first term, while substituting the first term, first look at the sine term. Okay, sine 2 of 2 pi, that is sine 4 pi. Sine 4 pi value is 0. Okay, so 0 into anything 0. So you have sub parenthesis, right? So plus cos, here while substituting 2 pi for x, that is here this term x, what happened? Cos 4 pi. Cos 4 pi value is plus 1. So 1 by 4 minus lower limit. If you replace this x by 0, what happens? 0. So 0 into anything 0 plus cos 2 product 0, that is cos 0. You know the value of cos 0, that is 1. That is 1 by 4. That's all. Simplifying this, you get 1 by 2 pi. Here what happens? 2, that is 2 pi square, here you have within the parenthesis, plus 1 by 2 pi of 1 by 4 minus 1 by 4. So 1 by 4 minus 1 by 4 means these two terms being cancelled. So you get 1 by 2 pi of 2 pi square alone. Okay, this term, second term becomes 0. So what happens? 2 pi, here one of the 2, one of the pi being cancelled. So you get a1 is equal to pi. Okay, so a1 is equal to pi. So we calculate the value of a1. Next we calculate the value of bn. So from equation 4, here the formula for calculating bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. Next step, replace the f of x by given function. So your f of x is x cos x sin nx dx. As usual, it's a product of three functions involving x. So we doesn't have any formula to evaluate this. So for that, what we are going to do here is, let me try to combine, is there any formula to replace these two, that is cos into sin. So for that, what I am going to do here is 1 by pi integral 0 to 2 pi x. I have to take this tan term first. So, okay, sin nx and cos x dx. Just interchanging the positions. Okay, that doesn't change the value of this integral. Am I right? So in the next step, you know 2 sin a cos b. So you know the formula for 2 sin a cos b, that is equal to sin a plus b plus sin a minus b, right? So for that, here you doesn't have any 2. Okay, so for that, what you are going to do next is 1 by pi integral 0 to 2 pi. So you just multiply this, that is multiply this term by 2 and divide the same by 2. So it doesn't change the value of the integral. 2 sin nx cos x dx. Am I right? This is of the form 2 sin a cos b. Instead of a, here you have nx, and instead of b, here you have x. So that is equal to 1 by 2 pi integral 0 to 2 pi x 2 sin a cos b. 2 sin a cos b is nothing but sin a plus b plus sin a minus b. That is sin a is nothing but nx plus b is nothing but x, sin a plus b plus sin a minus b, that is nx minus x of dx. So now what you are going to do here, you take these two terms of x outside of this, okay, parenthesis, so that will be easy for our integration. Okay, so in your next step, here bn is equal to 1 by 2 pi integral 0 to 2 pi x product sine of, if you take x outside, n plus 1x, here you have n minus 1x, am I right? So here you have x product sine of n plus 1x plus sine n minus 1x dx. So now I am going to divide this integration by, separate this integration into 2. So for that, so you take this x inside this parenthesis, that is 1 by 2 pi integral 0 to 2 pi x sine n plus 1x dx as one of the integral, plus 1 by 2 pi integral 0 to 2 pi x sine n minus 1x dx as your next integral. So what I am going to do here is, I am going to evaluate these two integrals separately and substitute in Bn and getting the value of Bn. Suppose if you know how to evaluate this thoroughly, means we have to do it in a single step, okay, no need to divide, okay. So now, so I am going to take this first integral as I3, because as I take I1, I2 while calculating An, so I have to take next as I3 for this integral. I name this integral as I4, okay, and you take this as equation number some B. So already I have to take A, so you have to take this as equation number B. So first let me calculate I3. So I3 is 1 by 2 pi integral 0 to 2 pi x sine n plus 1x dx. So now I3 is equal to 1 by 2 pi integral 0 to 2 pi x sine n plus 1x dx. This is of the form uv, integral uv dx, that is uv1 minus u dash v2 plus etc. So that is equal to 1 by 2 pi of u, what is your u? X, v1, while you integrating sine n plus 1x, you get minus cos n plus 1x divided by n plus 1, minus, this is your u and this is your v1, right? So next u dash is nothing but you have to differentiate this x, that is 1, and v2, integrating v1, so you have to take n plus 1 as a constant, so that is in the denominator, okay, while you integrating only minus also, okay, while you integrating cos n plus 1x, you get sine n plus 1x divided by n plus 1, already you have n plus 1 in the denominator, so you have n plus 1 the whole square with the limit from 0 to 2 pi. Next we make these two as positive, that is minus and minus become positive, take this minus to the front. So in the next step, 1 by 2 pi of minus x cos n plus 1x divided by n plus 1 plus sine n plus 1x divided by n plus 1 the whole square with the limit from 0 to 2 pi. Let me now substitute the limits, that is 1 by 2 pi, put a parenthesis, inside that you have sub parenthesis. So let me mark the portions of x, at these three portions you have x. So first if you replace x by 2 pi, so minus 2 pi of cos n plus 1 2 pi. You know the value of cos n plus 1 2 pi, that is equal to plus 1. Am I right? So that is equal to 1 divided by n plus 1 plus sine n plus 1 2 pi. You know the value of sine n plus 1 2 pi, that is 0. So you doesn't have the value for the second term. So minus, coming to the lower limit, if you replace this x by 0, 0, 0 into anything 0, plus sine n plus 1 0, sine 0. You know the value of sine 0. Sine 0 is 0. So there is no lower limit. Simplifying this, you get 1 by 2 pi of minus 2 pi of 1 by n plus 1. Right. So what happens? Here 2 pi and 2 pi being cancelled. So you have minus of 1 by n plus 1. So your I3 is equal to minus 1 by n plus 1. So let me substitute the value of I3 here. So I3 is equal to minus of 1 by n plus 1. Next we calculate I4. Your I4 is nothing but This is your I4. Am I right? That is 1 by 2 pi integral 0 to 2 pi x sine n minus 1x dx. Okay. Let me calculate. Now your I4. So your I4 is nothing but 1 by 2 pi integral 0 to 2 pi x sine n minus 1 x dx. This is of the form integral uv, right? Integral uv dx is equal to uv1 minus u dash v2 plus etc. So integrating this you get 1 by 2 pi, u is nothing but x, v1. So integrating sin n minus 1x you get minus cos n minus 1x divided by n minus 1. So this is your u and this is your v1. Next minus u dash. So differentiating x you get 1 and v2. v2 is nothing but integrating v1 once again. So you have minus 1 by n minus 1 as a constant. So in integrating cos n minus 1x you get sin n minus 1x divided by n minus 1. Already you have n minus 1 in the denominator. So you get n minus 1 the whole square. The limit from 0 to 2 pi. Now let me simplify. You take this minus to the front and make these two minuses. That is minus into minus as positive. That is equal to 1 by 2 pi minus x cos n minus 1x divided by n minus 1 plus sin n minus 1x divided by n minus 1 the whole square with the limit from 0 to 2 pi. Let me now substitute the limits. So 1 by 2 pi, put a big parenthesis, inside that you have a sub parenthesis. Let me mark the portions of x now. So at these three portions we have x. First let me replace this x by 2 pi. So in the first term look at this x, that is minus of 2 pi. If replace x by 2 pi minus 2 pi, cos n minus 1 2 pi is plus 1. Okay. So that is 1 by n minus 1 plus sin n minus 1 2 pi. Sin n minus 1 2 pi is, the value of this one is 0. So you have 0 for the second term. Upper limit minus, coming to the lower limit, if you replace this x by 0, what happened? 0. 0 into anything? 0. So the first term becomes 0 plus sin n minus 1 0. Sin 0 is 0. So there is no lower limit. Simplifying this, what happened? 1 by 2 pi minus 2 pi of 1 by n minus 1. So 2 pi and 2 pi being cancelled. So you get minus 1 by n minus 1. So your I4 is equal to minus of 1 by n minus 1. So this is our I4. So let me substitute this in equation B, that is equal to plus minus 1 by, your I4 is 1 by n minus 1. Okay. So let me substitute both I3 and I4. Now simplifying this, what we are going to do here is interchangingly we multiply. So multiply this numerator by n minus 1 and multiply this numerator by n plus 1. That is minus of n minus 1 plus, so plus into minus here itself you take plus into minus as minus. Okay, minus of n plus 1. So in the denominator you have n plus 1, n minus 1. Okay, so by taking minus inside, so you have minus n plus 1. Okay, here minus n minus 1 divided by, this is of the form a plus b product a minus b. A plus b into a minus b is a square minus b square, that is n square minus 1 square. What happens here? Plus 1 and minus 1 being cancelled. So you get minus 2n divided by n square minus 1. So we get the value of bn is equal to minus 2n divided by n square minus 1. As I told you already, while calculating the value of an or bn, if it consists of the denominator n square minus 1, so you go for calculation for b1, that is this value of Pn is true for all value of n except at n equal to 1. So if you substitute n equal to 1, what happens here? Denominator becomes 0. So if you substitute this value in a series, means you get f of x as the infinite series, right? So to avoid this, what we are going to do? So we go for the particular case, that is we have to calculate the value of b1. Now b1 is equal to, you know the formula for bn. Bn is equal to 1 by pi, that is the general formula, 0 to 2 pi f of x sin nx dx. You just replace this n by 1, you get b1. So b1 is equal to 1 by pi 0 to 2 pi f of x sin x. Now in the next step, we replace f of x by given function, that is 0 to 2 pi. Your f of x given function is x cos x, product sin x dx. You know the formula for sin 2a, right? Sin 2a is equal to 2 sin a cos a, isn't it? This is how the form. So this is a product of three functions involving x. So we couldn't integrate, so we have to combine any two of this and make it as a single, okay, using any of the trigonometric formula. 1 by pi integral 0 to 2 pi. This is of the form cos a, that is x, just take sin x front and cos x next, just interchanging the portion. Next step I am going to do. This is of the form sin a cos a. So if you have sin a cos a, what you are going to do? Or otherwise, let me do as we do in case of previous. You just multiply and divide by the value 2. What happens? That is 1 by 2 pi of integral 0 to 2 pi x 2 sin x cos x dx. I am just multiply and divide by 2. That doesn't change the value of the integral, isn't it? Because I have the formula for 2 sin a cos a. 2 sin a cos a is nothing but sin 2a. So that is equal to 1 by 2 pi integral 0 to 2 pi x. So 2 sin a cos a, that is nothing but sin 2a. So instead of a, here we have x dx. This is of the form integral uv dx. So b1 is equal to 1 by 2 pi integral 0 to 2 pi x. I am going to write it once again, the previous term. So x sin 2x dx. This is of the form integral uv dx. So integral uv dx is equal to uv1 minus u dash v2 plus etc. Isn't it? So by making use of this formula, let me evaluate the integral. So that is equal to 1 by 2 pi u is nothing but x, v1. So integrating v1, what you get? That is sin 2x, you get minus of cos 2x divided by 2 minus u dash, this is your u and this is your v1. Am I right? So u dash is nothing but differentiating x. Differentiating x, you get 1. And next integrating v1. So here you take minus 1 by 2 as a constant. So cos 2x, if you are going to integrate once again, so you get sin 2x divided by 2. Already you have 2 in the denominator, so 2 square. With the limit from 0 to 2 pi. So let me simplify this. That is 1 by 2 pi. You take minus to the front. Minus of x cos 2x divided by 2. So here minus and minus becomes plus sin 2x divided by 4. With the limit from 0 to 2 pi. Let me now substitute the limits. That is 1 by 2 pi of, put a big parenthesis, inside that you have a sub parenthesis. Now let me first mark the portions of x. At these three portions we have x, right? So cos minus of, first you replace this x by 2 pi, cos 2 product 2 pi, that is cos 4 pi. Cos 4 pi value is plus 1. So 1 by 2 plus sin 2 of 2 pi. If you replace x by 2 pi, you get sin 4 pi. Sin 4 pi value is 0. So 0 divided by anything, 0. Minus, coming to the lower limit, if you replace this x by 0, 0. The entire term becomes 0 plus sin 0. You know the value of sin 0? Sin 0 is 0. So there is no lower limit. Simplifying this, you get 1 by 2 pi of minus 2 pi divided by 2. So what happens here? So 2 pi and pi being cancelled. Am I right? So in the next step, so that is equal to 2 and 1 of the pi cancelled. So you have minus 1 by 2 alone. So your b1 is equal to minus 1 by 2. So we calculate all the coefficients. So let me now substitute in equation 1. I am going to write down the given from equation 1. That is general form of equation 1. That is from 1, your f of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos nx plus sigma n is equal to 1 to infinity bn sin nx. Actually, we have calculated a1 and b1 as a special case. So again, I am going to rewrite this as, so you have to take first term outside of the summation. For that, if you substitute n is equal to 1, what happens? a1 cos x, right? a1 cos x. Just replace this n by 1. So you get a1 cos x as the first term of the summation. And write down the remaining as summation itself. So 2 to infinity. Instead of 1 to infinity, 2 to infinity. Because ultimately take out of first term outside of the summation. So an cos nx. Likewise for bn 2. So you have to take the first term. So if you substitute n is equal to 1, b1 sin x plus sigma n is equal to 2 to infinity bn sin nx. Let me now substitute the values of a0, a1, a0, a1, an, b1 and bn. So the value of a0 is 0. Okay, so 0 by 2, 0 itself, plus the value of a1 we have calculated is pi cos x, and the value of n we have calculated is 0, right? The value of an we have calculated is 0. So 0 into anything, so the b doesn't have value of this summation. Plus next the value of b1 we have calculated just now is minus 1 by 2 sin x plus sigma n is equal to 2 to infinity. Bn value is minus 2n divided by n square minus 1 sin nx. Okay, so let me simplify this. That is pi cos x minus 1 by 2 sin x. You take minus 2 outside, minus 2 sigma n is equal to 2 to infinity n divided by n square minus 1 of sin nx. This is your f of x. So for the given function f of x equal to x cos x, that is given in the interval 0, 2 pi. This is for the Fourier expansion of the given function in the interval 0, 2 pi. So hope you got a clear idea about how to expand the given function f of x as a Fourier series. Thanks for watching. See you all again in my next video.